Hello physical science students, welcome to section 15.3 on using electricity. This is Tuesday on the day of recording. I hope you guys are going to have a great week. It's a short week, only 4 days, so hopefully we're going to be off to a good start. This is a shorter chapter, so let's take a look at 15.3. Inventions. Probably the most important invention in the late 18th, early 19th century was the incandescent lamp, invented by Thomas Edison. Now consider the fact that the incandescent lamp, of course, was something that ran on electric power. Most houses, did they have electric power? That is a negative. Most houses did not get electricity, some even into the 1900s. But the incandescent lamp was a great invention. It used a filament which glowed? Well, it would glow regardless when it was heated. And you can see how it might look. It kind of looks like something you might find in a retro coffee shop. And modern bulbs use something different. It's called a silica. It coats the entire bulb. And so the entire bulb lights up instead of just a portion of it. Because if just a portion of it lights up, a portion of the room gets lit, and it's not really all that great. And if you look directly into the filaments, your eyes are going to get those little patchy things you see when you stare at light too long. At least I do. Maybe I have bad eyes. Alright, let me move myself. Modern bulbs use either a halogen lighting system or a fluorescent lighting system. A halogen on the periodic table is a highly reactive element in column 17. These react with metals, in this case tungsten, to produce light. So let's take a look at our periodic table. And here I have one pulled up. This is the halogen column: fluorine, chlorine, bromine, iodine, adenine, and whatever they named this, the new name. We used to call it septinium, but it's since changed, since I've taken chemistry in college. Don't worry about the crying, that's just my child who's refusing to nap. Anyway, these halogens react with metals, in this case tungsten, and produce light. A fluorescent light bulb moves special gases through electrical discharges, causing them to glow. Phosphors can also be used to light objects. They're special isotopes. Now remember, an isotope is something that has the same number of protons and electrons, but different number of neutrons. So it looks the same, mostly acts the same, but in this case the phosphor is a little bit different, and it glows when exposed to radiation. And those are special kinds of light bulbs. Alright, give me just a second, I have a Skype call. My child has finally stopped crying, so I'm going to knock on some wood here, and hopefully it's going to stay that way. And I'm waiting for the blood-curdling scream to come about. But anyway, LEDs, light-emitting diodes, allow electrical current to move from one material to another at very low temperatures. And LEDs are actually more efficient, much more efficient, almost 10 times more efficient than a regular light bulb. And they're getting more and more cheap to make, which is very good. Solenoids convert electricity to back and forth motion. And one of the most important inventions, of course, besides the incandescent lamp, the telegraph, allows for electromagnetic impulses to travel for communication with Morse code. Now, I am no expert in Morse code. I do not claim to know Morse code. But Morse code, of course, is an international language made of a series of dashes and dots that can be used to talk about a certain thing or idea. Now, sorry, I'm going to deny this Skype call. Now, if you can tell me on an email the name of the first message that was sent through the telegraph. I will give you a bonus on this upcoming test. The first 3 that do that. It was in 1844, I believe. And it was 4 words. So, I guess you'll have to do some Googling. Kind of the last idea, electrical devices. A relay allows a magnetic field to turn a switch on and off. A loudspeaker converts electricity into sound waves. And although solenoids and similar devices are useful, the most important device is the electric motor. Hopefully we know what a motor is and what it does. It produces motion from electricity. And that's it. So make sure you get done section 15.3, page 364. And I hope that you have a very good day. And remember to email me. Alright, see ya.